So for today's 8-block e-learning day, we're going to be skipping ahead to 3.6, which is inductive reasoning. First, we're going to take a look at deductive reasoning versus inductive reasoning. We defined deductive reasoning, I believe, last chapter, and we've actually been using it all along, even if you don't realize it. But deductive reasoning is based on accepted statements, such as definitions, postulates, theorems, corollaries, things like that. In deductive reasoning, the conclusion must be true if the hypothesis is true. And we use this kind of reasoning when we write proofs, actually. So think of like our if-then statements, right? We only want to write true if-then statements in our proofs. Like if two angles are supplementary, then their sum is 90 degrees, right? These are things that, and we form conclusions on with those types of theorems and postulates based on deductive reasoning. Inductive reasoning is a little different, and it is based on several past observations or patterns. So when you observe a pattern and make a conclusion about it, that is inductive reasoning. So in this situation, the conclusion is probably true, but not necessarily, because it's simply based on a pattern or an observation. Deductive reasoning must be true because it's based on facts, mathematical facts. Inductive, it probably is, but it's purely based off patterns. So we're really just going to look at some examples with this. So for the first example, it says, look for a pattern and predict the next number in each sequence. So for part A, we have 3, 6, 12, 24. So inductive reasoning skills are observing this pattern and making a prediction based off what you see. Now with this 3, 6, 12, and 24, each number is actually twice the previous one. So we're going to say that each number is twice the previous number. That means that our next number would be 2 times 24, so our next number would have to be 48 based off of our pattern. For part B, we have 11, 15, 19, and 23. Well, with this one, if you take a look at the differences between each, 11 to 15, you would go up 4 units, 15 to 19, go up 4, 19 to 23, go up 4. So our pattern is that each number is 4 more than the previous number. So if we need to go up 4 again, 23 plus 4 means our next number would have to be 27 based on our pattern. And then for the last one of these, we have 5, 6, 8, 15. I'm sorry, 5, 6, 8, 11, and then 15. For these, there's nothing you could multiply each one by. With adding, we go up 1, then 2, then 3, then 4, though, right? So if you look at the differences between the numbers, this one's going up 1, then 2, then 3, then 4. So we could then make a prediction that the next time it would go up 5. So one way to describe this would be that the difference between the numbers increases by 1 each time. And there might be some other ways to explain that as well. That's just one example. So based on inductive reasoning, we could say that it's going to have to go up 5 next time, which would make the next number in our pattern 20. For number 2, it says tell whether the reasoning process is deductive or inductive. So if it's deductive, it's going to be based on theorems, postulates, properties, definitions. If it's inductive, it's based on a pattern. So for part A, it says Raymond noticed that spaghetti has been served. I'm sorry, can't read. Raymond noticed that spaghetti had been on the school menu for the past 5 Wednesdays. Raymond decides the school always serves spaghetti on Wednesdays. Well, you're making an observation, right? And you're making a conclusion based off that observation and that pattern. So this would have to be inductive reasoning. Then for part B, by using the definitions of equilateral triangle and of perimeter, Katie concludes that the perimeter of every equilateral triangle is 3 times the length of a side. Well, this is based off of mathematical definitions, so that would have to be deductive. For number 3, it says accept the 2 statements as given information. State a conclusion based on deductive reasoning. For part A, it says segment AB is longer than BC and segment BC is longer than segment CD. So if this information is all true, segment AB is longer than BC, but BC is longer than CD, so a conclusion that you could come to is that segment AB must therefore be longer than CD. So we would say segment AB is longer than segment CD. And then for B, 12 is greater than integer x, and integer x is greater than 8. Well, if 12 is greater than x and x is greater than 8, well, think about what numbers x could maybe be. X could maybe be 9. It could be 10. It could be 11. Couldn't be 12 because 12 is greater than it. And it also says integers. So we want to use lists of our integers, right? So we wouldn't want to write an inequality or anything here. We're just going to simply say that x is either 9, 10, or 11. And then for number 4, it says decide whether the statement is true or false. If it is false, show a counterexample. If it is true, draw and label a diagram you could use in a proof. List, in terms of the diagram, what is given and what is to be proved. So A says if a triangle has 2 congruent sides, then the angles opposite those sides are congruent. Well, we actually talked about that during the notes last time. If a triangle has 2 congruent sides, that makes it isosceles. And if it's going to have 2 congruent sides, it must have 2 congruent angles. That's absolutely going to be true. So we're going to state that this is true. And then it says to draw a diagram and label it. So I'm going to draw my triangle. I'm going to say this is triangle A, B, C. So the sides are congruent. So then the angles opposite those are congruent. So angle A would be congruent to angle C. So in your picture, you would have to mark the 2 congruent sides and the 2 congruent angles. And then your given is going to be basically your hypothesis, and then your proof is going to be your conclusion here. So based off of our picture, and depending on how you labeled your triangle, this might change. But based off my picture, my given would be that segment AB is congruent to segment CB. And my proof would be that angle A is congruent to angle C. And then for B, if 2 triangles have equal perimeters, then they have congruent sides. Well, this is not necessarily true because the perimeter is just the sum of all the sides, but you can have different combinations of numbers that come out to be the same sum. So this is false. And it says if it's false to provide a counterexample. You can do your counterexample in written form, or you can do a diagram. So I'll kind of show you visually first, where I'm going to draw two triangles here. They don't have to be drawn to scale. Really, what's important here is your labeling. I'm going to say that this side is 5 units, this side is 12 units, and this side is 10 units. Again, not drawn to scale. Your labeling is what's more important here. Now, if I found the perimeter of this, you would add up all your sides. 5 plus 12 plus 10 would give you a perimeter of 27. Now I could do the same thing. The triangle does not have to look exactly the same or anything. I'm just going to kind of draw a general triangle again. And this time, I'm going to give this triangle sides of 7, 13, and 7. Here, I'll actually label this one a little bit nicer for you guys. Again, it's the labeling that's more important, not what the picture looks like. So this is 7. I'm going to say this is 7, and then 13. Well, if I found my perimeter here, 7 plus 7 plus 13 is also 27. So in this example, I have two triangles that have equal perimeters, but their sides are not congruent. So this would be a good counter example, right? You could show the perimeter of one equals the perimeter of the other, but that the sides are not congruent. And if you wanted to do a little bit more of a written explanation, you could list out some side measurements, like maybe the measure of AB equals 5, the measure of BC equals 12, and the measure of AC equals 10, and show what that sum is, and then maybe do the same thing with another triangle and do it more as a written explanation. This is just a quick visual way to do a counterexample. Your homework is out of your textbook tonight. This will not be due until either Monday or Tuesday, depending on if you're in 4th or 6th block. That will be the due date for this. If you get it done before next class, that's great. I'm happy to answer questions on it. But I just figured since you guys will have all 8 classes today, I'd give you a little extra time. Let me know if you have any questions. Have a great day.